All right, folks, today we're going to take a look at section 11.2, which is properties of parallel lines. So this has a lot of the similar concepts that were talked about in 11.1. So one line crossing over two lines, but we're going to talk today about what special things happen when those two lines that are crossed over happen to be parallel to each other. So make sure you got something to write with and your guided notes there, and follow along and fill in what you need to fill in, please. Okay, so the first topic here is same side interior angles, which again is a concept that was discussed in the 11.1 video as well. But again, something special happens when they are parallel lines. So if parallel lines are cut by a transversal, then pairs of same side interior angles, so same side interior angles are supplementary. So Supplementary. And supplementary, hopefully we remember, means they add to 180 degrees. All right, so similar to all the angles inside a triangle, same side interior angles, when they are parallel lines, add to 180 degrees. And looking at our picture here, so L and M are parallel. That's what those little lines, or those little arrows, rather, that are on there. So there and there, that indicates that those two lines are parallel to each other. So since those two lines are parallel, we have a couple of sets of angles that are supplementary. Specifically, angle 1, oh, don't want highlighter, let's go back to pen. All right, so angle 1 and angle 2. So those two angles are supplementary. They're same side interior. So measure of angle 1 plus measure of angle 2 equals 180. And my other pair, 3 and 4, same thing. Measure of angle 3 plus the measure of angle 4 also equals 180. All right, our next is our alternate interior angles here. So again, same or similar thing that was talked about in 11.1, talked about alternate interior angles there also, but now when they are cut by a parallel line, so if parallel lines are cut by a transversal, then the pairs of alternate interior angles, are in this case congruent. Remember, that means they have the same measure. That's what it's going to mean for two angles to be congruent there. All right, so looking at our picture, again, L and M are our parallel lines. Alternate, remember that means they are on alternate or opposite sides of my transversal T. So angle 1 and angle 2. All right, and interior, inside or between my parallel lines, between L and M. So 1 and 2 are alternate interior angles. So angle 1 is congruent to angle 2. And similarly, we have 3 and 4 are also alternate interior. So angle 3 is congruent to angle 4. All right, next one is corresponding angles. So again, another concept that we talked about yesterday in 11.1. So corresponding angles. So if two parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent, which we remember is equal, same as those alternate interior angles. Corresponding, remember, on same side of the transversal, but one is interior and one is exterior. All right, so my first set, 1 and 2, so angle 1 is congruent to angle 2. All right, the next set, 3 and 4, angle 3 congruent to angle 4. All right, and then we have 5 and 6, angle 5 congruent to angle 6. And last set, 7 and 8. So angle 7 is congruent to angle 8. And those are all of the pair of corresponding angles between these two. And again, when it's parallel lines cutting through there, then these corresponding angles are congruent. All right, last one is alternate exterior angles. So parallel lines are cut by a transversal, then pairs of alternate exterior angles are congruent. So lots of congruent pairs of angles going on in here. Alternate, so opposite sides of the transversal. External, outside of my parallel lines. So my first pair, angle 1 and angle 2. So angle 1 is congruent to angle 2. And my second pair, 3 and 4. Angle 3 is congruent to angle 4. All right, and those are my alternate exterior angles. All right, our last thing here is talking about a perpendicular transversal. So remember, perpendicular forms a right angle there. So if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So if C and A are perpendicular, form a right angle there, okay, well then C is also perpendicular to B. And we need to recognize that the reason is because if A and C, lines A and C here are parallel, that's what these little arrows here mean, all right, well these angles in here are corresponding angles. And we know corresponding angles, when a transversal C cuts parallel lines, corresponding angles are congruent. So if one of them is a right angle, the other one will be a right angle, which makes these lines perpendicular to each other. All right, that is it for today.